Thanks for being here. I'm super excited to share my progress on Fireproof, a live database for React and front-end applications with a built-in browser IPFS that connects to Web3 storage. And I think it's ready for you to use to build apps. So I'm just going to dive right in, but you can come back to usefireproof.com to find the docs and do it yourself. This is a little app that I built that y'all can use to put your photos onto IPFS on customized photo galleries. So I'm going to kick off the login and it's sending me an email. So I'll go open my email client and here it is. I'll load up the email. This is just the end user verification from Web3 storage. So prove I'm a real person. I can click a link in my email. That was easy. Uh, so in the background, let's see, the sync is going to be starting. So I'll move that over. We can see stuff come in as it goes. Let's talk about the Fireproof architecture, starting from the Fireproof write path from the browser to the cloud and back to the browser again. So each logical update that you make in your application is going to be written to the CRDT, the conflict-free replicated data type. This keeps a logical ordering of all the updates, whether or not there are forks or merges, and makes it so edits from multiple users converge when they come in from across the network. It simplifies a lot of what we're doing, but it's also in mechanical sympathy with the way that IPLD and IPFS data structures like to work. Once those updates are written to the CRDT, they're indexed into a Prolly tree, which is another IPLD tree. This one is designed to be hash consistent. What that means is that different replicas that may apply operations in a different order or with different batching strategies will have the same CID for their whole index at the end of all those operations. This simplifies a lot of stuff and allows you to share subsets of the index and do all kinds of other database tricks. Fireproof is going to persist to the browser, and that persistence is going to be replicated to the cloud so it can go to other browsers. So every time you do operation against the CRDT or the Prolly tree, you're going to get these IPLD, IPFS blocks. And for a series of operations that correspond to a transaction, we're going to wrap those up in one car file and put a header block on the front. So the history of the database is each transaction is a car file, and you might take all the old transactions and wrap them up together into a compaction so that you don't have to load so many files. You get faster performance for your web reads, especially for new users. So let's look inside these car files. First of all, they're encrypted. That's what this blue line represents. So the blocks inside of them can't be served by the IPFS infrastructure, but the car files can be validated. Inside of the header block, there is a list of all the other car files that you need to complete the data set, with the oldest one being either the first car file in the database or a compaction that corresponds to the database at that point, snapshotted and written to a single file. Now, how do we maintain consistency with multiple replicas? So in the browser, there's a write-ahead log that keeps track of which car files have been replicated to IPFS and which ones still need work. And after each unit of work is completed, writing to IPFS via Web3 storage, then we update W3 clock, which is a cloud resident version of the same pale clock that we use logically inside of the database. And here you could see a couple more representations of how the event structures can work. So this allows you to have as many concurrent workers as you want. You can read from this latest state of the database. You can read arbitrary states and fold them back into your overall data structure because these CRDTs and Prolly trees are idempotent. So you could just throw updates in and it's safe. And it makes it very easy to operate the database. So all this runs on IPFS, but I also have versions running on S3 and REST backends, etc. Let's go back to the demo. Here's an already logged in account that's got a bunch of fun data, and I've got a flowers album and a glass album, and I'm going to customize this. I'm going to put these orange ones up at the top, And I'm going to set the columns to 4, and I'll go ahead and hit the publish button, and let's see what happens. So this is just a regular IPFS link. I think we're logged in over here, so I'll do a refresh, and yeah, there we are. So now you can kind of see these side by side. If I pop open the flowers, there's the ordering we saw. And I'll go ahead and add a few more files so you can see what it's like. This is just uploading it to Web3 storage. Here are those files. I want to make an album called Crowds because I'm kind of happy with some of these AI generated crowds I did in Stable Diffusion that are in my image library. So I can go get those, and then from one of my other imports, pull in the rest of the crowds, and we can go look at it all together and share that album with the world. Here, let's do it like this, and we'll have an album. So that's fun. It's nice to be able to customize your data and have a blend of private and public data. All the metadata that's tracked in the gallery app is encrypted, but when you publish it, it goes straight onto IPFS. And you can get inside of that encrypted data if you want by importing it into the Fireproof dashboard. So this is just loading up those car files and bringing them into this user interface where we could see them. So we can, drill into one of these and see this is there was 41 files uploaded in this transaction, etc. And you can go and manage all your databases in here. So that's just the beginning of understanding what you can do with Fireproof and using it to write apps that run on IPFS. There's a handful of other apps out there. This one orchestrates LLMs, and there's starter kits, etc. So you're encouraged to go out and write your own apps using the starter kit, and it's got built-in login, it's got a built-in data model, all the routing's done. You should be able to win some app building contests in no time.